You find the Taylor series for the function. If it's centered at 0, it's just called Maclaurin. It's basically the same thing. Okay. So, coming up with the Maclaurin series for like sine and e is just annoying. Like it just takes a while, okay, to find. So like if you did it the long way, so this is like if you get desperate on the AP test, okay, you could just create the Taylor series for it if you really wanted to. Okay, because then what you would do, if I want Maclaurin, that means I'm centered at 0, and I'd follow the formula, right? So I do like f of 0 plus f prime of 0 x. I don't have the minus c thing. Well, technically I do, but it's 0, so I'm like, not going to waste my time writing minus 0 on there. And then I would do like the second derivative at 0 over 2 factorial times x squared. So I'm literally following the formula. See, like f of 0, f prime of 0 times x, f double prime of 0 over 2 factorial times x squared. I just didn't like write the minus 0 part, right? And then I could keep going and do the triple over 3 factorial x cubed, da 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 da. Okay, so what I'd have to do all the time is I'd be like, okay, what's f of 0? What's f prime of 0? What's f double prime of 0? What's f triple prime of 0? I'd have to like figure those all out and put it over the factorial. With e, since its derivative is always like e, this one actually isn't as painful as some of the other ones, because if you plug 0 into e, you always get 1. So like e to the x, its Maclaurin series is f of 0 is 1 plus 1x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed, yada, yada, yada. And if I like just made it look a little cuter, where I just wrote it like without the 1s in there because that looks kind of dumb. I'm just going to write 1 plus x and then x squared over 2 factorial plus x cubed over 3 factorial, yada, yada, yada. You can come up with a pattern of what's going on with like how that's looking, okay? And that's how you come up with like this business here, right? Is like these functions follow a pattern, so you can come up with like that part of the series. So it's like you write it all out and then you notice a pattern, and if you notice that we get, it's always x to whatever n value it is. So like we started with 0, then 1, then 2, then 3, then 4, then 5, whatever. Like it would go 0, x to the 0 is the first term, x to the first is the second, x to the third, squared, whatever. So it'd be x to the n, and then it's always n factorial because you kept increasing whatever you're taking the factorial of. So then what they say is now it's like, hey, I notice a pattern. E is if you start at 0, because that's where my center is, right? So I'm going to start at 0 on this one, is x to the n over n factorial. And if I did what we did yesterday, okay, so if I did like the full like ratio test, interval of convergence, you might be able to see this. If you can, like, might be able to predict if I did ratio test what the limit would be. And it would be 0. So my interval of convergence is from negative infinity to infinity. So this is like to come up with this yesterday's stuff. Right? So that's like ratio test, ... Okay? I'm not going to do that because it's going to take too much time. Okay? But this is if you get desperate, right? So you would have to do all these derivatives, use the Taylor series formula, write it out, and then come up with a formula on your own. So E is one of those you should just know because it's so famous. It's kind of like in calculus world, like remembering the square root of 9 is 3. Like in really simple terms. It's kind of like something that's like so famous you just kind of like know it or should know it. You could do the same thing for sine, but if you think about it, like if you did sine all the time, it's like it changes between 1, 0, and -1 all the time if you're thinking of all your derivatives. So it's like you could do it. You could do like f of 0 is 0, and then like f, well, the derivative, or derivative sign would be cosine. And then I'd have to plug 0 in, so that I get 1. And then I'd have to do the second derivative, negative sine. Second, plug it in. Guys, why are you talking? You get 0, do the triple. Do you know what I'm saying? Like, it takes forever to do this. And this is just so you can get a vibe of what this equation is going to be. So in my experience is don't do it the long way because it takes way too long. Plus, we're going to be integrating these. We're going to multiply them. We're going to plug stuff into them. We're going to be deriving them. It's just going to be like wild. So it's like some of them you really should have committed to memory. So that's why they've been on your test, so you don't have to deal with that now, because already this math is hard. Now you have to, on top of it, memorize it. I mean, some of you waited to the last minute, so like good for you, I guess, but you're going to kind of struggle with it. But you technically can do it the long way, okay? Because technically this would be 0 plus, and then it would be 1x plus 0 over 2, 0 over 2 factorial, that seems kind of dumb, x squared minus 1 over 3 factorial x cubed and dot, 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 right? And if you notice, especially with sine and cosine, I feel like I would need more terms to get a pattern. Because like, two of my terms, I did 4 derivatives, or like 4 values, and I only get 2 terms out of it, because I get a dang 0. So it's like, it helps, like I said, to commit to memory. So this would be sine x equals, and then this would be x minus x cubed over 3 factorial. And hopefully you do have them memorized, but next one would be 5. And then, again, if you kept going, you'd have to come up with a pattern for sine. Right? So this is another thing where it's like, okay, sine, you're only dealing with odd powers. And it's alternating. So the alternating is that piece. Your x, the power on x is always odd. So odd means 2n plus 1. Even is 2n. Okay. And then this is all over. And again, your factorials are always odd. Because like technically this is over 1 factorial, but that looks kind of dumb. So that would be 2n plus 1 factorial. So again, you had to have to come up with that looking at the patterns. So, I don't know. Cosine's similar, but it's even. And cosine's an even function. Crazy! So anyway, oh, look at these. Cute. Hey, remember all these? There you go. All right, so we're going to like mess with them. Basically, okay? So technically, yes, you could come up with it, but it would take a while to do it. This one's cool. I just want to show you this one because this is the first one that's on the list. Okay, 1 plus x squared plus x cubed, blah, blah, blah. That's just geometric series. It's kind of cool. So just like, hold on a sec. Because like, I'm going to just do n equals 0. Why are we doing k? It's weird. Okay, so remember for like a geometric series, you remember like the form of it was a sub 0 was like your first term. And then you would get the ratio to whatever n, right? That would be like the formula for it. Thanks. And then, so then if you were to say like your first term, if I plugged in 0 for 0 in, my first term would be 1, okay? And then my r would end up being x. So then when I set up like the sum formula, I would take the first term, a sub 0, over 1 minus whatever my r is. Like that's the formula for a series. And if you think about it, you did 1 over 1 minus x as the series. Here you have your first term is 1. Sorry, do you get how I came up with 1? If I plugged 1 in, or plugged 0 in, I get 1 from the function. If I plug 1 in times, and then x is my ratio, x to the n, ends up getting my series. It's kind of fun. So it's just a geometric series is that one. You can see it through in the problem. You see how 1 is on the numerator, that being your first term, and then it's 1 minus r, like you know your formula for geometric series. So this one you could actually come up pretty fast without taking derivatives, just by seeing that it looks like a geometric series sum. Like it's the same formula or same idea. All right, so let's get into the gist of this. It's basically, you're going to find a Maclaurin series for not just sine x, but you're going to do sine x squared. Okay, you're not just going to go e to the x, you're going to do e to the x times x squared. Okay, cosine of 2x, right? So it's kind of a little wild dealing with. It's kind of like hardcore algebra in a way, in like exponent rules. So this is what you do. You realize, hey, it's sine. So then you say to yourself, hey, I know what sine is. You know sine starts with what? X minus x cubed over 3 factorial plus x to the 5th over 5 factorial. I usually do a couple, 7 factorial, dot, 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 and then you get alternating x to the 2n plus 1 over 2n plus 1 factorial. Okay, so it's like you just pull that out of your brain, okay, and you have to be able to do that. So commit it to memory, and then now all you do is if you're doing sine of x squared, you're just gonna, it's like you're plugging in the x squared where there's an x. So like I said, like this first one's actually not that bad, in my opinion, because instead of all the x's, you're gonna plug in like x squared. So it's gonna be like x squared here, minus, and then this is the part where like the exponent rules, people make all these dumb mistakes. Not you guys though. Other people, right? And you're gonna have to plug in x squared and then cube it. You know what I'm saying? So you're just plugging it in. Fancy plugging in. The worst part is at the end. Actually, it's not even that bad. Because at the end, you have to come up with the fancy thing at the end. Okay? So just like how you did all the other ones, you're just going to do the same thing. Like people way overthink this part. So you're going to plug in the x squared into like all the crazy stuff. And then just don't mess up any exponent rules and you'll be fine. Okay? So your series is if you like simplified this hardcore thing. So it'd be x squared minus, now do you add the 2 and the 3 or multiply them? There you go. 6 over 3 factorial plus x to the 10th over 5 factorial minus x to the 14th over 7 factorial, blah, blah, blah. And then now, again, people freak because it's all like, you know, not numbery, but it's like you multiplied those all the time, right? So you're just going to multiply this. But now just make sure you distribute. So it'd be 4n plus 2. So it'd be x to the 4n plus 2 all over 2n plus 1 factorial. And then that's it. So it's not horrible, horrible. It can be tricky. This one's like my favorite kind. Okay. Okay, next one. Now we have x squared times e to the x. Now x squared doesn't have like a polynomial thing. It is a polynomial, so it feels weird. But you do know e to the x. So you're going to write out your e to the x. So 1 plus x squared over 2 factorial plus x cubed over 3 factorial, blah, 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 till x to the n over n factorial. And you're bringing that out of your head, okay? And that's your e, okay? Again, you kind of can figure it out. That one's not as horrible, but you could technically figure it out. And then what are you going to do? Hardcore algebra. You're just going to multiply everything. Think about if you multiply both sides by x squared, okay? You're going to have to distribute the x squared to every single term, right? So it's basically, I'm going to do x squared times 1 plus x squared times x plus x squared, I mean, you get the idea, times this thing. And again, it's just hardcore algebra. And then probably the part people freak out the most is the last guy. So you're multiplying everything by x squared. These ones, you'd add the exponents. So then your grand finale would be what? X squared plus x cubed plus x to the 4th over 2 factorial plus x to the 5th over 3 factorial, dot, dot, dot. And then just like how you did all the other ones, you added them. I like the n when it's first, so that's just me, but it'd be n plus 2 over n factorial. So the x's are only affecting the x's. Don't do anything to the n's. And that'd be it. Okay? Yeah.
Do you have to show that second line, or can you just...
You could just go straight, yeah. Yep. Okay, this guy, find the 4th order Taylor polynomial that approximates y equals cosine 2x near x equals 0. That's code for Maclaurin. Okay, so that one, it's easier because I don't have to do all the derivatives. I don't have to create it because cosine I already know what it is. So what I'm going to do, my strategy for this one is like cosine of x, I know what it is, right? It's 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, x to the 6th over 6 factorial. And then it's alternating, changing sign. All the powers on the x are even, and it's always an even factorial. That's how I remember that one. Okay. But here's the deal for this one. When it asks for the 4th order, what that means is if I just want the 4th order, I just want the 4th like power. Okay. So I don't need this general term. They don't want that. I don't need to the 6th power. So really all I need is the first 3 terms. So those kind of problems, all you do is like the chunk of it. So here you're going to do cosine, and it's like that other one. You're going to plug in 2x wherever there's an x. So don't plug it in for 1. There's no x with 1. I've seen that happen, so don't do it. You're not multiplying everything by 2x. You're doing the cosine of it. So you're going to be plugging in. It's like you're plugging in the 2x. So this is going to be 1 minus, and then here's another one. Drives me nuts is people don't know how to square it. That's fine. So you have to plug in 2x, and make sure that you actually are like squaring the 2x. Oh, to the 4th. What's wrong with me? That's scary. Okay. Raising something to the 4th power, just square it and then square it again. So 2 squared is 4, and then 4 squared is 16. So when you simplify this, this would be 4x squared over 2 factorial, and this would be 16x to the 4th over 4 factorial. And then they usually expect you to simplify that. Okay, especially multiple choice likes these. And they're usually simplified on no calculator. So just FYI. That one's not too bad. That one should just be 2x squared. The way I simplify out the 16 is like this guy. 16 is 4 2's, because I literally just did that. And then this is all over 4 times 3 times 2 times 1. And then what I do is I'll just like, okay, a 4 is going to knock out 2 2's, and then we got a 2 dividing out, so it ends up being 2/3 is how I figure that out. Thirds, x to the 4th, and then that'd be the answer. So just don't forget to simplify it. I wanted to do one like that. And then this one is they're making you go backwards. When does this end? 5 minutes? Shoot. Okay. This one's making you go backwards. Honestly, these ones can be tough because you have to really, really, really know your Maclaurens. Okay. So for this one, notice that it's not alternating. Right? So if it's not alternating, these are out, right? Sine and cosine, because those are alternating series. Natural log 3, the natural log one was like a little wild, so I'm kind of like dealing with that one later. But you need to recognize that this series looks very similar to E. And you have to just pull that out of your brain. There's not like a trick to it, which is tough. It's just kind of like being, oh, this looks familiar. And instead of all the X's, they put 3's. Do you know what I'm saying? So instead of all the X's, they put a 3 there. So they must be finding e to the 3rd. So when they give you a series, you have to like pull out of your brain all the different ones you have memorized to see which one it looks like the most. Okay. When you got adding ones, this one's kind of weird. Okay, start with your cosine, because that's the only one you kind of know. So cosine x we know is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. Do I have to do the general? No! Yes! Okay, this one says write the first 4 non-zero terms, so I don't need the general. Guys, can you stop talking, please? Okay. So then what you're going to do is, again, do all your algebra junk. Okay, I'm going to add 1 first because it's first in line. That's the only thing. So I'm gonna do add 1 to both sides. So what does that turn into? 2 in the front. Everything else stays the same. Ah. Right, because I did 1 on 1, 1 on both sides. Now I'm gonna add x squared to both sides. So it's gonna be 1 plus x squared plus cosine x. So I'm gonna have to add in the x squared part to it. So the 2 is from adding the 1, and I'm gonna combine like terms. I'm not gonna like distribute x squared. I'm not multiplying, I'm adding it. So I'm gonna add x squared just to this guy. So I kind of like, I'm kind of gonna like put these together later. Oops, minus. So then you're gonna have to actually do, okay, 2 factorial is 1/2, right? Or that's a 1/2 in front of the x squared. So then your final answer would be 2 plus 1/2 x squared. Because you're doing 1, because this is like 1 minus a half. Plus x to the 4th, 4 factorial minus x to the 6th. So like I said, it's all like hardcore algebra. Sometimes they make you fill out the factorials. That's 24 instead